This question says, a student dissolves 13 grams of sucrose, C12H22O11, in 425 milliliters of solvent with a density of 0.98 grams per milliliter. The student notices that the volume of the solvent does not change when the sucrose is dissolved in it. It says, calculate the molarity and the molality of the student's solution. So, molarity, we learned in General Chemistry 1. Molarity is equal to moles of solute divided by liters of solution. Molality may be a new unit for you. Molality is similar but a little bit different. The molality is equal to the moles of solute divided by kilograms of solvent. And the reason that this new unit is needed is for temperature studies. Molarity is not a good unit of concentration to use if you're studying temperature. And the reason for that is, as a solution's temperature changes, its volume changes, and therefore its molarity changes, right? Because liquids will expand and contract as they're heated. They expand, as they cool, they contract, which will actually change the molarity of the solution. The molality, on the other hand, will not change. So these words are very similar, right? They only differ by one letter essentially, but the units are very different, because if you have kilograms of solvent, kilograms doesn't change, mass doesn't change with temperature. So volume does, mass doesn't. So if you're doing temperature studies, molality is what we use. So in both cases we need moles of solute, and the solute is sucrose, so I'm going to figure out what the moles of solute is. 13 grams of C12 H22O11 times 1 mole of C12 H22O11, and 1 mole of this compound is 342.30 grams of C12 H22O11, which gives us 0.037978 moles of, in this case, C12H22O11. Note that this is two significant figures, so that's the sig fig that I care about. Now we need to find molarity, the big M. Okay, molarity has a unit of big M. Then we can take the moles and divide by the liters of solution, and here it says the solution volume doesn't change, so this is the 425 milliliters of solvent. So we take the moles, 0.037978 moles, divided by the volume in liters, so divide by 1,000, 0.425 liters. And when you do that math, you get 0.089 molar, big M, to two sig figs. Remember that the moles was actually two significant figures because it came from the grams, which was two significant figures. In the case of the molality, which has a unit of small m, we need the kilograms of solvent. Well, we're not given this in grams or kilograms, we're given it in milliliters. So we need to do another conversion. We need to take the 425 milliliters times, we know the density, it's 0.98 grams per milliliter, which means there are 0.98 grams per 1 milliliter. Milliliters cancel, and you end up with 416.5 grams. So now we can find the molality. We take the same number of moles that we found before, 0.037978 moles, and we now divide by this in kilograms, so we have it in grams, we have to divide it by 1,000, 0.4165 kilograms. We just took that and divided by 1,000. We then plug in, and we get 0.091 molal with the small m. You'll notice that in this case, the molarity and the molality are very close together. That has to do with the fact, one, that the solution volume didn't change, which it will with a concentrated solution. probably even a solution this concentrated, although the math is easier if the solution volume doesn't change. Secondarily, the density is very close to 1. Okay, it's 0.98 grams per milliliter. If it's not very close to 1, that'll have an effect as well. So sometimes they're very close, other times, especially for more concentrated solutions or where the thing is not having a density close to 1, they can be substantially different. So these are molarity and molality.